For decades, science fiction has promised us laser weapons. Sleek, silent, and overwhelmingly powerful. From Star Wars to Star Trek, these energy weapons seemed like the inevitable future of warfare. But here in the real world, despite significant advances in directed energy technology, the machine gun remains the backbone of infantry support weapons. Why is that? Why can't laser weapons simply replace their ballistic counterparts? The answer lies in fundamental differences in physics, logistics, and tactical application. While laser weapons offer some spectacular advantages in specific scenarios, they face critical limitations that machine guns simply don't. Today, we'll explore the technical and tactical reasons why laser weapons can't replace machine guns, at least not yet, and examine where each technology excels. Number 1. Fundamental operating principles. Let's start with how these weapons actually work. Machine guns are fundamentally mechanical devices that harness chemical energy. When you pull the trigger, you're initiating a controlled explosion that propels a physical projectile down a rifled barrel. The machine gun uses either recoil energy or gas pressure from these explosions to automatically cycle through feeding, chambering, firing, and ejecting cartridges. This cycle of functioning includes 8 distinct operations: feeding, chambering, locking, firing, unlocking, extracting, ejecting, and cocking. It's a beautifully mechanical process that has been refined over more than a century. The result is a stream of kinetic projectiles that can penetrate cover, ricochet, and transfer significant energy to targets. Laser weapons operate on completely different principles. They're directed energy weapons that use electricity to generate photons, concentrating them into a coherent beam of light. This beam travels at the speed of light, meaning there's virtually no travel, time to target, and works by transferring thermal energy to the target's surface, literally heating it until it melts, vaporizes, or suffers structural failure. Number 2. Critical limitations of laser weapons. Now let's examine the fundamental limitations that prevent lasers from replacing machine guns. First, and most importantly, atmospheric vulnerability. Laser beams are dramatically affected by environmental conditions that barely bother traditional firearms. Rain, fog, dust, smoke, smog, or even heat haze can scatter, absorb, or distort laser beams, rendering them ineffective. This phenomenon, called thermal blooming, occurs when the laser beam heats the air it passes through, causing the air to expand and defocus the beam. It's such a significant problem that after decades of research, it remains largely unsolved, according to weapons experts. In essence, lasers require clear air or a vacuum to operate effectively. A machine gun, it will fire in a sandstorm, through smoke, in pouring rain, conditions where lasers simply fail. The second critical limitation: massive power requirements. Effective military-grade lasers need tens to hundreds of kilowatts of power to engage targets at useful distances. The smallest combat laser prototype draws about 10 kilowatts, equivalent to powering an entire house. More powerful systems like the 300 kilowatt Valkyrie require enough electricity to power 30 households. And because lasers are only about 50% efficient at best, they generate tremendous waste heat that requires extensive cooling infrastructure. This means liquid cooling systems, heat exchangers, and all the weight and complexity that comes with them. Meanwhile, a machine gun needs nothing more than perhaps a barrel change when it gets too hot, a process that takes seconds in the field. Third limitation: engagement time. Unlike bullets that deliver instantaneous kinetic energy, lasers require sustained focus on a target for several seconds to deliver enough thermal energy to cause damage. This dwell time means the laser must remain precisely aimed at exactly the same spot on a potentially moving target while atmospheric conditions remain stable. During this time, the weapon platform must remain steady and the target can't move behind cover. Finally, let's talk about target effects. Lasers primarily work through thermal heating, which makes them less effective against heavily armored targets or materials designed as heat sinks. Unusually thick metal plate armor can dissipate the heat rapidly, rendering laser attacks moot. Certain materials can even be designed to attract lasers away from vulnerable areas. Traditional armor-piercing machine gun rounds, like those from a 50 caliber M2, deliver massive kinetic energy that can penetrate armor and cause catastrophic damage to vehicles and equipment. Number 3. Tactical advantage of machine guns. Now that we've seen laser limitations, let's examine why machine guns remain tactically indispensable. First and foremost, reliability. Machine guns work in virtually any environment: jungle, desert, urban, Arctic. They're relatively simple to maintain, can be cleaned in the field with basic tools, and don't require specialized technical support. Office full of repair parts on the front lines. Perhaps the most underappreciated advantage is psychological impact and suppressive fire. The sound of machine gun fire, the visible tracers, the impact of rounds on terrain. These create powerful psychological effects that keep enemies pinned down. Lasers are silent and invisible to the naked eye, producing none of these psychological suppression effects. You can't walk laser fire onto a target using tracers, and enemies might not even realize they're under attack until damage occurs. Machine guns also offer incredible versatility through ammunition selection. A single machine gun platform can use ball ammunition, armor-piercing rounds, incendiary, tracer to help aim, and even less lethal options for crowd control. This flexibility allows soldiers to adapt instantly to different targets and scenarios. Laser weapons typically have limited adjustment, primarily between lethal and non-lethal settings, but can't match this tactical versatility. Then there's the economic reality, cost-effectiveness. While laser shots cost between $1 to $10 per activation versus millions for missile interceptors, machine guns remain dramatically cheaper to produce, maintain, and operate. The manufacturing infrastructure for firearms is well established worldwide, while laser weapons require specialized components, rare materials, and highly technical expertise. Finally, consider tactical mobility. A light machine gun, like the M249 SAW, can be carried and operated by a single soldier, fired from the shoulder, hip, or bipod, and moved quickly across complex terrain. Laser weapons, with their massive power requirements and cooling systems, are currently limited to vehicle-mounted or fixed positions. You won't see soldiers storming a building with laser rifles anytime soon. The technology simply can't be made portable. Enough with current physics. Number 4. Current state and future outlook. This isn't to say laser weapons don't have their place. Several systems have found successful niche applications. The U.S. Navy's Helios system protects ships against drones and small boats. The Army's DE, these systems excel in specific defensive roles where their speed of light, engagement, and unlimited magazine provide decisive advantages. The key insight is that lasers complement rather than replace traditional weapons. As one defense analyst noted, high-energy laser systems are a better match to the threats we now face versus the threats 10 or 20 years ago, particularly referring to cheap drones that make expensive missile interceptors economically unsustainable. But even their strongest proponents acknowledge they're part of a combined arms approach, not a wholesale replacement. Military leaders are clear about current limitations. General James Mingus of the U.S. Army states bluntly, "Our high-energy lasers are so susceptible to weather. Anytime there's a dust storm, anytime there's that kind of thing, it starts to alter the physics of the light particles." Lieutenant General Daniel Karbler adds that lasers are complicated compared to conventional vehicles and weapons, requiring specialized support not available in forward areas. So why can't laser weapons replace machine guns? The answer lies in fundamental physics, not just technological maturity. Machine guns work reliably in psychological any environment, suppression, offer versatile ammunition effects, and remain cost-effective and mobile. Laser weapons, while revolutionary in specific applications, remain vulnerable to weather, require massive power and cooling, lack psychological impact, and can't match the tactical versatility of kinetic weapons. The future likely holds a place for both technologies. Machine guns will continue as the reliable backbone of infantry firepower, lethal, versatile, and effective across the full spectrum of combat environments. Laser weapons will increasingly protect high-value assets from emerging threats, like drones and rockets, precise, cost-effective against appropriate targets, and unbeatable for speed. But the idea that lasers will completely replace the timeless machine gun? That remains firmly in the realm of science fiction. In the end, warfare isn't about having the most futuristic technology, it's about having the right tool for the mission. And for the foreseeable future, that tool will often be the humble, reliable, and devastatingly effective machine gun.